Redshift tables, databases. You see Redshift, Amazon Redshift. Serverless. Yeah. Same only. Go to work. So page action. Query data. Where is the create cluster option? First option should be create cluster, which was earlier here, but now I think they have changed somewhere. Maybe create workspace. Hmm. So basically processing unit RPU. Again here, previously we had option to select something like node. Where is this option? Now it is completely saying serverless. Just our base unit.
Sir, in left panel, once you check, sir.
Maybe provision, this one.
Yeah,
Provision means fix.
yeah.
Right, let's click here. Maybe now they have divided to serverless. Yeah, here you see create cluster option is there.
Yeah.
So now they have two options. One is serverless, where you should not create the cluster. Right. You cannot select the nodes. But if you want to go for fixed resource based, then go for provision cluster. Correct? Others, are you getting the point?
Yes, sir.
Yes, sir.
Right.
Yes, sir.
So in the provision one, if you see, if I create a cluster, click on a create cluster. So let's say cluster name. Let's say MK Redshift cluster 1. Right. I will choose or help me choose. Both options are there. Since we are just using for learning purpose, 4x large machine contain, you see, it can store the data up to 128 terabytes per node, which is too much. I don't need that much for practice purpose. No, for practice purpose, DC large should be sufficient. DC too large. Do we have option DC too large? DC, yeah. DC too large is fine. You see, it has a 2 V cores and every node can store 160 GB. Yeah, that is fine. Anyway, we don't have any smaller machine than this. This is the smallest we can get. Okay. DC to small is there? No, no, not there. Only large is there. DC to small is there? No, uh, only large. So we'll select this version. A number of nodes. We'll go for 2. So here we are fixing it. Right. Load sample data. Do you want some sample data? Let it load so that uh, it is going to load the data in the ticket data set. Some tables will be created. Okay. So let it load so that we'll have some data already loaded. Right. Then admin password. Generate a password. Manually add admin. Admin password. So username will be this AWS user. AWS user. Let's give the same password. AWS user 321. We'll give password. So password AWS user 321. Okay. Then role. Which role? So password assign role. Associate role. Which role will give? I have already created a role called my MK redshift role. I would have given. I think this one role I have already created. My MK redshift role. So I will associate that. If you want to see in this role what I have done, what permission I have given, that also we can check in these roles. This is role. What permission I have given? You see, Amazon S3 read only access. Amazon S3 read only access is given. Yeah, because to load the data from S3 and all, this is needed. That's it. Yes. Amazon S3 read only permission. Okay. So far fine. This role. Then let's go for anything else we have to select. We selected node IAM. Then if you want to access Redshift cluster from some client, then go to the cluster properties, public access, enable it. But do we have that option here? Or it will be after creating only. So create cluster. Cluster is getting created. You don't create a cluster, you use the same cluster. I'll give you permission. Don't create a cluster, just use the same cluster. Just for running the query. And you see it support JDBC 4.2. Right. If you want to download the connector, you can download JDBC or Microsoft Windows. Right. Those driver can be downloaded. Wait for the cluster to be created. Let's see. This cluster is created or not. Modifying means creating. Okay, meanwhile, let's understand. Cluster is getting created. Let's understand Amazon Redshift Spectrum, which is a query engine of Redshift, query engine. So what Amazon Redshift Spectrum provides? Run SQL query directly against data in S3 using thousands of nodes. Okay. So when you use Redshift, you have storage and compute both available. But when you use Amazon Redshift Spectrum, the queries which we run in the Redshift, right? That can be used for running the SQL queries against the S3 data also, same as Athena, right? So it is used for fast and exabyte scale, elastic and highly available, on-demand pay per query, high concurrency, multiple clusters will be created with the same data, no ETL, query data in place using open format. They are saying no ETL, but actually we will do ETL always, right? And then SQL queries, right? So when we execute a query, let's say we are executing a query in S3, sorry, in Redshift, which is which is which is let's say accessing the data from S3, right? One second, I'm coming. Yes, one second. Just give me. I'm coming in 1 minute. Right, I'm back. Right. So what I was saying, if we see even in the Redshift spectrum, we can run the query for S3 data also. It is not mandatory that in Redshift spectrum we have to run the query only for native Redshift tables. We can even run the query for the external table whose data is stored in the S3. Are you getting the point? So then in that case, what Redshift spectrum will do, let's say a business application has submitted the query, something like this: select count star from S3 external table, group by on something. The query will be received by the Amazon Redshift cluster, where leader node will take the query and transform that query into SQL plan, and according to the plan, assign the task to the different compute node to get the work done. Then that compute node internally will use Redshift spectrum cluster shown in the green color here, green color spectrum cluster, to run those tasks, because the data is in S3, so it will run some processes on those spectrum nodes to scan the S3 files, to do the data filtration, all those activities, and then finally the output of the query will be returned to the client. So in the step number one, query is submitted. In the step number two, you see query is optimized and compiled at the leader node, determine what gets run locally and what goes to the Amazon Redshift spectrum. Then in step number three, the query plan is sent to all the compute node. Then compute node obtain partition info from the data catalog, glue catalog, dynamically prune partitions. Then for each compute node issues multiple requests to the Amazon Redshift spectrum layer. Now, spectrum layer, and then Amazon Redshift spectrum node scan your S3 data, and then Amazon Redshift spectrum select those columns, project columns, filter, join, and aggregate the data, right? And then final aggregation and join with the local Redshift table happens on the Redshift cluster. Let's say you're doing a join between one external and one local table. So that join will take place in Amazon Redshift, not in the spectrum. But the reading the data from the external table will happen in the spectrum. And then query result is sent back to the client. Are you getting the point?
Sir, here one question is like the data catalog table should be there to read data, right, sir? Receipt main
Correct.
mandatory is the. Okay.
Correct. Data catalog is your common meta store. Common meta store. Getting the point? Let's revisit once more. So let's say we are performing a join query between native Redshift table and one external S3 table. To perform that join, we can submit the query to the Redshift cluster from our client application, right? Then the query is optimized and compiled at the leader node of the Redshift cluster. The leader will determine what gets run locally and what goes to Amazon Redshift spectrum layer. Because for local table, it will be done locally, but for external table, it has to go to the spectrum layer, right? So then query plan is sent to all the compute node. Query plan is sent to all the compute nodes, right? Then compute node obtain partition info from the data catalog, dynamically prune the partition which are not needed, it will remove it. For the partition which are needed in this query, only those will be considered. Then for those partition, each compute node issue multiple requests to the Amazon Redshift spectrum layer. Amazon spectrum layer scan your S3 data. So scanning S3 data is responsibility of spectrum layer, not the responsibility of Redshift layer, right? Then Amazon Redshift spectrum layer will perform projects, filter, joins, and aggregation on those S3 tables data. Then final aggregation and join with the local Redshift table will happen inside the Redshift cluster, and then query output be sent back to the client. Getting the point? Getting the point, friends?
Yes, sir.
Right?
Sir, that green blocks will be Amazon Redshift Spectrum only, no?
Correct. Green is spectrum, the blue is Redshift, and this one, the last one is S3, and this database is data catalog. Okay, right. So now let's go to the our cluster and see. Hmm. Cluster is running, you see available. right? So we can go inside a cluster, right? Inside a cluster, and we can run query data. Click on a query editor version 1 or version 2. Let's go for version first one only, query editor, like this. Here select the schema. Why schema is not there? Connect to database. I click on connect to database. Create a new connection. Database name. What was the database name? We haven't created database. Hmm? We haven't created a database, I think. That's it. No, database was created. This is database name. No, this is cluster name. Is this
Sir,
the?
sir,
Previously,
sir, that database you are taking from, I think, Postgres or something, right?
No, 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 not Postgres.
Not that.
Here, database means inside Redshift, the columns which you are going to create for what database you want to create those columns.
Okay, I think this we not yet created then. We created only cluster.
Correct. We
So
created
if
only
I remember
cluster.
correctly, while creating cluster, we chose default database something, right, sir?
No, no, that was public schema.
Okay.
Right, schema. If you want to access, but this database. Let's see once more. Create cluster. Compute node. Sample database connection. Assign username. We assign. And then we manage password. This we did. And then this. And then this. There was no option to create a database here. Cluster. This is cluster. Cluster name is different. Database is different. This one
Right,
we
sir.
selected.
I
That
think here
was one
load
ticket. This was a ticket sample schema
database
and
called
sample
ticket.
data.
Yeah, sir.
Right, ticket. So go inside a cluster. There's option add delete. Where is option to create database? Store table. Not there. This JDBC URL is there. Oh, but you see, the name is given as dev only. I think by default the database name is this only, dev. Can you see?
Yes, sir.
Okay.
So by default itself, you see JDBC URL is this. JDBC.
Yes, sir. Port number is also.
Right. Port number is same. So JDBC URL is there. Remove for a timing. So dev is there. So the port number is also same. Right. Okay. Then query data. Go to query data 2 maybe. Right. This is a cluster. You see cluster name is this here, saying the principal tag of your IAM role and user must be prior to connection detail. You configure this tag in IAM, and you see by default is database name dev. Username we have to select.
Sir, we have database username and password no? In this case.
Correct. We have database username and password. This username is this.
I think we need to opt the database username and password.
This one.
Yes.
And then this password. Then create connection. You see, dev database is there. and some sample data is also there. Ticket, can you see? Right.
Yes, sir.
And AWS data catalog is also there. The current user is not authenticated. Okay, maybe some authentication issue. We'll see that. Okay, in here dot what is there here? Edit connection, delete connection. This is just connection name cluster. In the dev here, if I right click, public is a schema name. Public is a schema name. Is copy schema name. This is schema name, right? Database name is dev. Public is a schema name. We can create a schema also. Uh, create a schema command. Let's see. Let's type it here. It will create a schema. You see schema. Mukesh. Run. Done. Right. Create a schema. Mukesh is done. Now refresh it. Can you see Mukesh schema is also there? Can you see?
Yes, sir.
Yes, sir.
Right. So it's key. The inside the database is schema. Inside the database is schema. Then we can say use Mukesh. Use Mukesh so that we will be. I think use command is not supported here. Not supported here. Right. You have to
You
here only.
use
No, use
use
command is not
schema,
supported.
Mukesh.
Use schema. Mukesh. No, not there. Maybe we have to directly in the table name. We have to attach the. Let's say here we are creating one table. Let's create a table. Create table users. And in this table, you see, we are saying user ID is integer, not null. And this column we are using as distribution key or sort key. I will explain about what about this distribution sort key. But understand that this column user ID is going to be used for distribution key and sort key. Distribution key means based on this column now Redis is going to distribute the data into different slices of this compute node based on this distribution key, right? But distribution style we are not selecting it. We had discussed some time back. There's something called key distribution style, all distribution style, correct? Round robin
Yes.
style. That style also we can confirm, we can configure. But by default we are going with auto. Auto means automatically it will go for a hash partitioning. Same key, right? So, and this same column is sort key. What is the use of this? We'll discuss. And then we are defining username, char 18, first name, last name, city, state, email. Okay, rest of the thing you know. Just before the table, say Mukesh dot users and run the query created. So if you refresh Mukesh table, if you refresh in the table, it should have users. Can you see? And these many fields are there. And when you click on that, it says that user ID is your short key and short type is compound by default and distribution key is user ID. And these many columns are there. Are you getting the point?
Yes, sir.
Right. Let me create another table. Venue. Again, Mukesh.venue. And in this venue ID is your distribution key and short key. Okay. Now let me go to another table. Category. In this also is cart ID, category ID is the distribution key and short key. Okay, let me run this query also. Complete, done. Those many tables would be there now. If I refresh it, you can see these many tables are created. Right, this one is date. Let me just copy paste. Anyway, these are create table command. And as of now, we have seen how to use a column as distribution key and part short key, but we haven't seen how different column. Now this first time we are using some other column as a distribution column and some other column as a short key. You see, so event ID is a distribution key, right? But date ID is a short key. We'll discuss more about it. Right. Then here listing. In the listing also, list ID is the distribution key and date ID is the short key. Just we want to explore all the options. Done. Then this sales table, similarly, sales list ID, distribution key, date ID, short key, and there is no primary. As of now, one thing you have seen, whatever tables we have created, I have created, in none of those tables I have defined primary key or foreign key. Though we can define, but I have not defined in these examples. I have defined distribution key and short key, but primary key, foreign key not defined. So now I have these many tables created. Right? All of you go ahead and create these many tables also for you. You also go ahead. And I will give you the permission. I am permission, then only you can query it. All right. So everyone, please use your name to create a schema, and then before the table, use that schema name before all the tables. Yes. I have to give permission to all of you. Otherwise, it will not work. So anyway, I have created a group. AWS data engineering. I have to attach permissions, add permissions, attach policy, and I say Redshift. I will give you, which one should I give? Let me first try with full access. I don't want to give.
Sir, query editor.
Query editor should be sufficient, or full access. No, full access means everything then. Right, we'll go with this query editor. Yes. Now go ahead and check.
Excuse me, sir.
Hmm.
Actually, I don't have the access to AWS account, so can you create a user for me?
Hmm. Please write in your email ID
Yes.
in the
Sir,
chat.
it is accessible.
Okay. Please confirm. Are you able to create your own date schema in a dev
Sir,
database?
Sir, we are, sir,
it
we are
is
getting from
asking.
configure account. Yes.
Hmm?
Configure
So,
account
yeah.
or something.
So the user information could not be retrieved. Account information could not be retrieved. We're getting this pop-up message.
Okay. So better I should give the complete full access, huh?
I think no one should create a cluster. I think we should be very careful.
Yeah, use the only cluster, don't create it. In this, you create your schema, your table, that is different thing, but don't create a cluster. I think query editor does not have that permission. Yes, go ahead. Now refresh and see.
Sir, can you share the database name and database user? Uh,
Database name? Dev, no? Dev.
and database name is there.
Hmm.
Database user.
AWS user and AWS something password is
Oh,
there. So
you,
I think you
okay.
have typed it.
That one.
Okay, username. Okay, username, password. This one, username, password, this.
Yeah.
Let, let me copy in the codes here.
Lavanya, are you able to access it? I'm still not able to access. I'm getting user information now.
Refresh it. I will share you the snip. Wait. I will share you the snip. 1 minute. In chat, I'm sharing you.
Which query editor we have to select? There are two, na?
Oh.
V2 and
V2, go for V2.
So for me, still
Sir,
it
for
is
V2, it is not accessible.
Yes, sir. That's what I'm saying. For V2, we are getting user identified something, sir.
But full access I have given, no?
Sir, in V1 itself, query editor only, it is. I've
Opening.
created schema. There it is. It is asking for your username and dev. 1 minute. I will do in that.
Okay, share a screen. Share a screen. Let me check what you
Yes,
have.
sir. I will share. I think for that, I think we are
It is
getting.
not accessible.
Should I share or
Yeah,
someone?
yeah.
Can I share a screen, sir? I think
Mhm.
user account information could not be retrieved.
yes, so we are getting the same.
Yes, sir, same.
Account information could not be retrieved. I am user
And the AWS encryption setting of configuration.
But I'm not getting this error.
I think you are using query editor 1. We are using query editor. We have to use version 2.
For V, it is not giving error.
Yes, in query, it's one we can open. I can see
Okay.
that.
Okay, let me check once more. Wait, let me check if any other extra permission needs to be given. Now try refresh this screen and see. Refresh this. Wait for 1 minute.
Still, it is
This-
coming like that only, sir.
No, it should not come. It should not come. Why you are configuring account? Account is configure
Sir,
account should not come.
query editor V2 it is coming like that. In query editor V1 it is coming properly
Yes, sir.
actually.
This is query editor version
Sir,
1, sir.
one in that it is
Correct.
working.
Correct.
In that it is working properly. Dev you give
Temporary no, no, no.
dev. Database name is dev. That is correct. Database name you give dev.
No, but
That
why
one.
you are getting temporary credential? This should not be there, no? Authentication. This should not be there. Temporary connection.
No, correct. Give connect. Create Abdul. I've created already my schema in this actually.
I think where is select schema is in the left side. It is
You
not showing
create
view
you
table.
create your schema. Create
Okay,
create schema Abdul.
that will work. I just wanted
Uh,
to see them.
create schema Abdul. Run it. Oh, okay. Okay,
Then
in that checkbox you will get your schema. In drop down, public drop down is there, na? You will get your schema.
hmm,
Yeah.
Sir, here we can create the tables. Is
correct.
it okay?
Yeah,
We're
fine.
in
Same.
correct path, right?
Correct. Now you create the
Now,
tables.
now Abdul needs to Abdul dot he needs to give, right? Same way I
It
need to
doesn't
give.
need. Already, I think he has selected his schema,
Yeah, there is
Abdul.
no need to give the schema
Okay,
name.
okay.
Just remove them.
Hmm, hmm. Are they? Maybe by default it is going in some other, not going
Yeah.
in Abdul. So you have to add only, I think, Abdul dot user. Hmm. I think by default it goes in public, I think. Public schema. Yes, now created. We have to write. We have to use schema name dot table name. Hmm,
Yes, sir, it's created.
right.
I stop sharing my screen. Sir.
Yes, yes. You create the rest of the tables also.
Yes, sir.
And just see how we are using a column to be used as distribution key and short key.
Sir, I got something exception,
Hmm.
expected exception.
Please share the screen.
Yes, sir. Can you see my screen, sir?
Hmm.
Yeah.
Unexpected. What is this? Have you? You are using my IM role only, no? IM username to connect.
Yes, sir.
Refresh this screen.
Yes, sir. I'm already I've clicked on your cluster name. Maybe it's
Are you
Sir,
able to
it
see
is
my cluster?
asking. Sir, it is asking to
yes,
sign
sir.
in her because our sign in got expired.
Yes, yes. So he has to sign in again.
Yeah. Kavita, log out and log in again. Or open new tab. Close this tab.
Okay.
You can see now. Go to the left panel. There it is there. Redshift.
Yeah, it's loading. Still. I'm signing in. Can you see my current screen,
Yeah.
current screen or okay?
Yes.
I thought I'm lagging.
Yes, sign in. Correct. Go inside Redshift.
Yes. First
Correct.
one,
Cluster.
right, sir?
Yes. Yes. Query data. First one.
Yes, sir. Now we are connect to database, right, sir?
No, no. Here you can create your own schema by create a schema command, and then no, not needed. Connect to data. Already you are connected.
Okay.
Or connect
No,
to
sir, I
database.
think we have
Right.
to
Connect
get
to
connected.
database. Connect to
Correct.
Connect to
database.
database, sir.
Username,
Then
password
only
you
we
have to
can.
give. Username,
Yes.
password.
Okay.
Yes.
Okay. Connect.
Right. Connect to database. It will ask username, password. I have given the username as AWS user. Written in the line number 998 in the codes here. Username, password. Hmm. Why your screen is frozen?
It's loading, sir.
Yeah.
Sir, I'll
o-
carry from now on, sir.
Okay. Yes. 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 You can stop sharing the screen. Right. Others, I hope all of you have created. Right. I can refresh and see that these many people have created their own database. and tables, right? Now, how do we load the data into these tables? For that, we are going to use copy command, something like this. Uh,
I think this is the S3 folder taken,
correct.
and this is the, I think, the file. I think we have to write, sir. And it will
Yes,
be a
yes.
text file that we will be copying, which contains data.
Right, right. Yes. So what I will do, I will create this bucket in S3. Let's go for S3 bucket, S3, and see whether that bucket is already there. May not be there. Is this bucket there? No, not there. Ticket MK. So we'll create a new bucket. Ticket MK1. Ticket MK, maybe it will say initially enabled. We'll say object writer. Created ticket MK. In that we are going to upload these files. Uh,
The Redshift can directly read a text file, right, sir? Whereas in, I think for data frame
no, Redshift, we have to upload this file.
yes,
Already table we have created, na? Table we have manually created.
yes, sir.
Now only we are going to load the data. So all user underscore pipe. Where is all user underscore pipe? Here. Do we have data? Correct only. You see, call data is there. Header is not there. Only data is there. Separated by pipe delimiter. Correct. Pipe delimiter. So all these files we have to upload in S3 bucket here.
So do we have to upload in S3 only, or we can upload in Redshift also?
No. First we are uploading in S3. From S3 we will be loading the data into Redshift.
Okay, sir.
I think for Redshift, sir, we can directly upload from JDBC connection. And anything else we can do
Correct.
that also, right, sir?
Yeah, correct. Why not? You can use JDBC connection to directly write in Redshift. That JDBC connection you can open in the AWS Glue job and directly write the data into Redshift. But
Yes.
let's say you have written a Glue job which has generated a data in S3, and that S3 data you want to load it in the Glue also. Sorry, in the Redshift also. Then we can use this option, copy command.
Yes, sir.
Get the point? See, in certain scenario, this will be the better approach, that you use the Glue job to write the output into S3, and whenever you want to run a Redshift style queries on that data, then go and create a table, load the data into Redshift and run the query, and then terminate your schema once your query is done. Anyway, data is saved in S3 again, already saved. If you want, you can recreate the table again, once again. Getting the point?
Yes, sir.
So destination details, permission, any permission is there now. S3, you guys may not able to read it, I don't know. We have to see, because this file is in my account. This file you will not able to read it, right? Unless I make it as a completely public. Private grant read access. Okay, leave it. You can create your own. Let me first complete this demo and then you can. Yes, the file is uploaded. Now I can go ahead and run this type of query. in the query editor here. Copy user table. Here we have to say Mukesh database, otherwise it will not know which Mukesh from this. Correct. Credential IAM role. Yes, delimiter is this, region is this one. Right, let's run. Done, completed. Can you see these many records? Friends,
Yes, sir.
Yes.
right, these many records uploaded. So copy command, this is what is called as copy command.
Sir,
I will, mm,
sir, where
yeah.
where we saw that one?
When we execute this command, it will say how many
Okay,
data.
okay. I
Right,
missed it.
similarly, yes. Similarly, we will say copy venue from here. Copy venue. Let's do it. You see, I will do it again. Copying the data into venue table from this particular S3 bucket using this AWS role, Redshift role. I have created it, my MK, and in this role, I have provided S3 read permission. So it is able to read this, and then using pipe delimiter, it is able to read the data and load the data.
Sir, I think you have to give Mukesh dot venue.
Right.
Correct. Mukesh.venue. Yes, done. 202 records loaded. Getting it? Let me copy this command in the codes here. And then this was similarly copy category. Yes, this is also done. Then date. Yes, this is also done. Then event. Done. Then listing. Done. Then copy sales. This is failing. Some date
Sir, we are
format.
able to access using the same S3 bucket, sir. I think it's loading
Okay,
data.
good. Okay, good. Because that role you are selecting, that role has already read permission. My MK Redshift role you are selecting, right? This role itself has S3 read permission.
Yes, sir.
That is the reason. But now this one is last one is failing. Time format, it's saying error invalid timestamp format or value. For sales, the format is some issue date and month. In the sales, what data is there?